Alright, hello everyone, this is Mr. Crozier. I'm going to go through our homework tonight and give you some help on it. So here we go. Number one, is it a function? Well, yes, every straight line drawn down is a function on this graph. Number two, domain. The domain is the furthest left on the x to the furthest right, and the furthest left on this axis is negative 15, and the furthest right is positive 10, so there's our domain. And the range is the lowest value up to the highest value on the y-axis. So on the y-axis, the lowest value is down at negative 5. The highest value is up at 15. So left to right. Inputs and outputs. F of 3, input 3, output negative 3. I put about negative 3.1. Input negative 5, output negative 5 also right there. The next one says, what is the x value when f of x is 5? So that's saying what is the output, or sorry, what is the input when the output is 5? And there's a spot right here. At this point right here, the output is 5, and the input is negative 12. And there's a spot over here where the output is 5, but the input is about 4.6. So you have to, about right there, so you have to look for both of them. This point right here has an output of 5, and this point right here has an output of 5. All right, x-intercepts. Well, that's where it crosses the x-axis. Negative 10, 0, and 3.6, 0. Y-intercept. Where does it cross the y-axis? 0, negative 3. That's that point right there. Increase intervals. Well, first interval I see is from here down to here, and that's from this point on the x-axis to this point on the axis. Between negative 15 and negative 5, it's going down, and then the graph starts going up, so it increases from negative 5 to this point. So between negative 5 here and negative 2, the values are going up, and then it's constant. From negative 2 to 3, it's constant, then it goes up, then down. So you can read this graph as going down, going up, going constant, going up, going down. Relative minimums, a point right there. It looks like a valley. Relative maximum, a point right there. Looks like a hilltop. When is the function greater than 0? Well, this interval here and this interval here, these two places, this side and this side. And when is it less than 0? Well, from this point in time to this point in time, from negative 10 to 3.6, it is below the x-axis. Average rate of change, and that's what I have drawn here in this red line. From negative 10 to positive 5, from this day to this day, the graph goes up. And we just subtract. 5 minus negative 10, 15. 6 minus 0, these are the outputs. Outputs over the inputs. We went up 6.8, and you can see it right here. Up 6.8 over 15, and that's called a slope. It's called an average rate of change. And I would simply reduce the fraction. And on the bottom one, same deal. It's this dashed purple line. From day negative 15 to day 5, it is going down. And it went down 8.2 in those 20, it went down 8.2 in those 20 values right there. All right, now we're going to do the same types of questions without a graph. Difference quotient, 2x squared plus x, 2x squared plus x, but in this case, x has been switched to 3 plus h, minus 21. Do a lot of algebra, comes out to be 13 plus 2h. F of 9, put 9 in here, do the fraction work, 53. Put 36, or put 6x in here, 6x squared is 36. 2/3 of 36 is 24, minus 1. Don't forget the minus 1. On the next one, I wrote this in here, I FOILed it, I distributed the 2/3 in there, and I have all of these, but then this one can be simplified because 8/3 minus 1 is 8/3 minus 3/3 is 5/3 here. When you have a piecewise function, what you have to do is determine which one you use. If it's less than 4, we're using this top row. If it's greater than 4, we're using the bottom row. And I did the computation with the right row. Number 15, list any zeros. Well, that means what numbers do I put in for x, and I get a 0 out. On the graph, we wrote it like this. If you input 3 halves, you output 0. If you input 4, you output 0. Domain, 2 red flags. If you have a fraction here, the domain is every number but the numbers that make this 0. So set this equal to 0, solve it. The domain is all numbers except for -5 and 3. These numbers are not part of the domain because they'll make it 0. It changes the graph, and that's what we'll learn coming up next week. Domain here, you can't square root a negative number, so this inside has to be greater than 0, greater than or equal to 0. Solve the equation. Don't forget to flip the sign. All real numbers as long as x is less than -4. And on here, let's see here, domain here, you can see it. It goes left to -3, right to 4. The range, the lowest to the highest, -1 to 4. When is it greater than or equal to 3? Well, right here is this output of 3. And we have this section here, which is -3 to -2. And we have this section here, which is 2. Whoops, this should be a 4. 2, 4. And the last one, what inputs give an output of 0? 0.4 gives an output of 0. And 1.2 gives an output of 0. All right, hope this helps with your work on functions.